let's talk about digestion. As we go through the digestive system that you can see here, we're going to look at digestion from two different perspectives. And one of those is what kind of digestion is happening at any particular point. And by what kind, I mean, are we talking about mechanical digestion or chemical digestion? Mechanical digestion is physically breaking food down into smaller pieces. Chemical digestion is going to involve enzymes or other chemicals that are chemically breaking down your food. So both of those things are possible, and so at each step along the way we'll look to see which one or perhaps both might be occurring of those things. The other perspective we want to look at digestion from is what kind of nutrient is being digested at each step. Is proteins, carbohydrates, or fat being digested in this particular spot in the system as we go? So what kind of nutrient digested and what kind of digestion will be something we want to ask ourselves at each step. The first thing we notice at the beginning of the system here at the mouth are these salivary glands. And salivary glands produce saliva, and you actually have probably more of them than you thought you did. You can see here the largest of the salivary glands right here, the parotid glands. There's one on each side right in front of the ears. There's also underneath the tongue here is the sublingual gland and the submandibular gland, sort of next to each other underneath the tongue there. And so there's really a pretty good number of these salivary glands producing the saliva. And the job of the saliva really is to do two things. One is to contain enzymes which digest carbohydrates. So we've given you some clues right here about what happens in the mouth. Enzymes, carbohydrates. So carbohydrates are the nutrient being digested in the mouth. Fats and proteins really don't get any chemical digestion in the mouth, and then enzymes make this chemical. You've perhaps never paid a whole lot of attention to your tongue, but ask yourself, what is your tongue doing while you're chewing food? So here's another piece of the puzzle. Because you're chewing, the teeth are mechanically digesting food, chopping it up into smaller pieces. But the tongue is also assisting with both mechanical and chemical digestion. The next time you're chewing something in your mouth, pay attention to what your tongue is doing. And what it's doing is it's constantly stirring the food around inside the mouth and churning it up to give the teeth equal access, as well as to ensure that the saliva gets equally stirred throughout the mouth. And at the end of that process, it will form a swallowable chunk of stuff. We'll get to that in a little greater detail here in a minute. This happens to be a slice through the small intestines, but the general tubing of the digestive system is set up with this idea of a very muscular tube. So that tells you there's going to be some muscular contractions going on that are a significant part of digestion here. And then there's going to be obviously a good blood supply and an inner and outer lining to it. So if we think about the mouth here a little bit more, we can see the tongue there. This is looking from the front, and it's going to do the stirring. The saliva is going to come in from the sublingual and submandibular glands. Right here you can see some of these pores right around the bottom edge of the tongue where it attaches to the bottom of the mouth. The parotid glands at the side of the mouth in front of the ears there are going to dump their contents in at the back top of the mouth. And so if you feel kind of a funny burning sensation at the back top of the mouth, sort of in front of the ears there, that's the parotid glands releasing saliva. And if you feel that same sort of sensation underneath your tongue, that's the submandibular and sublingual. We can see the teeth here, and you've got teeth that are specialized. The teeth in the front are more for slicing and cutting. The teeth in the back are more for grinding. So it makes sense that you start by slicing things into manageable pieces, then you grind them into smaller pieces, all the while stirring it around with the tongue and the saliva. So we've already had a couple of mechanical steps here of making the food smaller and smaller physically, and then chemically it will start to digest again the carbohydrates. If you've ever taken a nice bite of, let's say, your favorite bread at your favorite restaurant, you might notice that after a few seconds of chewing, it feels like there's not nearly as much there as there was when you started. And that is because the saliva and the enzymes in the saliva are able to digest carbohydrates that quickly. So a great deal of carbohydrate digestion actually occurs in the mouth and in the esophagus on the way down. And that probably gets at least half of carbohydrate digestion done there in just a few seconds. Once you've chewed that food up, your tongue has stirred it around, equally exposing it to chewing, equally exposing it to saliva, and now it's time to swallow. And the swallowing process is actually a fairly complicated neurological sequence, but the main step is this. You have formed a bolus, so that enzymes, the saliva, it helped to digest carbohydrates, but it also helped to make that food into a sticky ball. And that sticky ball was what we call the bolus. And when you swallow, the tongue is going to throw that bolus to the back of the mouth and initiate the swallowing reflex, which is something that once it starts, you cannot stop it. And once the swallowing reflex is initiated, that food is no longer under conscious control ever in that process. So at the back of the mouth, a really important thing happens. You can see here the epiglottis, this little flap that had been over here open. So here's the trachea where air is going to go down to the lungs. So before you swallow, it's open to allow air through, but when you swallow, it closes, hopefully completely closing off the trachea. Because here at the back of the mouth in the pharynx region, the esophagus and the trachea were both relatively open in terms of something could go down either way until you swallow, and then hopefully that closes because you don't want food to go down the trachea to the lungs. If you do, that's called choking. And so sometimes that food passes actually past the tracheal opening like it's supposed to, but it might get stuck right here. And one of the foods that's famous for that is mashed potatoes. If you didn't get enough butter in the mashed potatoes, they're kind of sticky and they might hang up a little bit, or some other foods. So what could happen is the epiglottis could open back up for the next breath to occur, and then it might actually suck that food back up and down into the trachea, and then have a problem then. So if the epiglottis fails to keep the food from going down the trachea, then you're going to have choking. And then you have the Heimlich maneuver to actually hopefully be able to blow that particle of stuff back up out of the trachea where there's another chance for appropriate swallowing to occur and to open the airway. Once that bolus actually enters the esophagus, it undergoes a process called peristalsis. Peristalsis is muscle contractions that start at one end and work smoothly to the other end. So the esophagus contracts from top all the way to bottom without bouncing around back and forth. So this means that the esophagus really is a one-way tube. Also, because it is a muscular contraction that's pushing that food down, you can actually be standing on your head or hanging upside down in a zero-gravity environment, swallow, and that food will still, or even liquid for that matter, will still go to the stomach. Might feel a little funny. It might be a little more prone to choking, but the muscular contractions are still quite capable of pushing it through. Which means astronauts in space don't have to hang upside down while they're eating for things to float to the stomach. The esophagus pushes it there no matter what gravity says. While in the esophagus, there is some mechanical digestion occurring because it's contracting, it's continuing to stir the food, and the enzymes from the saliva continue to digest carbohydrates. So in the esophagus, we have both mechanical and chemical digestion occurring there. In the stomach, there's going to be mechanical digestion because the stomach will start to contract and relax, basically sloshing and stirring that food back and forth. And the stomach does a couple of things. One is that it sterilizes food. So stomach acid there in the stomach actually starts to sterilize that food. No matter how carefully you handled the food, no matter how carefully you prepared it, there are likely still some organisms on or in that food that could possibly make you sick. And you all know that there are lots of places we get food from every day that probably aren't perfectly clean and handling things properly. So those places would be even more likely to have pathogens still in the food. And sometimes what we don't know won't hurt us. Well, what we don't know, we don't have to think about until it does hurt us. But that stomach acid will start to help sterilize by killing those pathogens. And most pathogens we would consume in our food would be sterilized or otherwise inactivated by stomach acid. Also, the stomach is going to hold food until the small intestines are ready for it. And the third functionality is that it is going to liquefy the food. So it was a relatively solid bolus that went down the esophagus, and the addition of the stomach acid helps to liquefy that food. When we look at food poisoning relative to sterilizing food, it most commonly occurs at Thanksgiving is the #1 time of year in which it happens, and 4th of July is typically the second most common time of the year for food poisoning. At Thanksgiving, often things don't get handled quite as well as they should with keeping things hot or keeping things cold. It sits on the counter too long, it sits on the table too long, it sits in a refrigerator that can't cool it off fast enough too long. We tend to sit around and eat it when it's sitting on the counter and not been kept at a proper temperature. And perhaps the bigger piece of this puzzle here is we eat too much. So there's simply so much food in the stomach acid cannot adequately sterilize it all. At 4th of July, the problem is we leave all that food sitting out on the picnic table all day and fail to keep it hot or cold that way. It turns out that bacteria that cause food poisoning, and really all bacteria for that matter, with a few exceptions, like things warm. Not hot, not cold, but warm. So to help avoid food poisoning, keep things hot or keep things cold. If you can't keep it hot, keep it cold, and that will really help to reduce the growth of that bacteria and reduce the likelihood that it will cause a problem. So while it's liquefying, carbohydrate digestion stops because the enzymes that were there digesting the carbohydrates are inactivated by stomach acid. So proteins and fats start to become digested here, and basically they're becoming liquefied by the stomach acid. So it's mechanical digestion mostly, a little bit of chemical, but not a whole lot really of chemical going on there. So over the course of a couple of hours, usually 3 to 4 hours, that stomach liquefies the food, sterilizes it, and then slowly releases it to the small intestines. And basically the small intestines are going to take it a little bit at a time. So literally a squirt at a time, completely liquid, will enter the small intestines here. Before we move on into the small intestines, we need to talk about a problem that sometimes happens with the stomach. And that is what we call acid reflux, or gastroesophageal reflux disease, or heartburn, whatever you want to call it. The point is, the esophagus was supposed to be a one-way tubing from the mouth to the stomach, and the food once in the stomach is not supposed to come back out into the esophagus again. So there's an esophageal sphincter, a muscle around the end of the esophagus that closes off once the food goes into the stomach, and it's supposed to keep that liquefied acidic stuff from coming back up out of the stomach into the esophagus. The stomach is lined with mucus so that the stomach acid doesn't bother it, but the esophagus is not. So if that acidic stuff comes back up into the esophagus again, it starts to chemically burn the esophagus, and that's where the feeling of heartburn comes from. That burning sensation is coming from the acid burning the esophagus. The solution for that is to perhaps short-term take an antacid, but that shouldn't be a long-term approach, because if you're chronically taking antacids to basically neutralize the acidity of the stomach, that's really starting a chain reaction. And that chain reaction is the stomach says it's not acidic enough. Let's make more acid. Then you cancel it out with more antacids. Then it makes more. Then you cancel it out and it makes more. So what you really did was you drove the stomach to a higher rate of acid production, actually making this problem worse. Short term, it's okay to treat symptoms, but long term, that's not useful for being a real solution to the problem. So what's the problem? And then we can figure out a solution. There's a couple of different contributors to acid reflux or heartburn, and one of those might simply be a weak esophageal sphincter. So some people very quickly learn that they cannot eat within a certain amount of time before going to bed, because when they lay down, they get heartburn. And that's probably a weak esophageal sphincter, and when you lay down, gravity is now pulling that stuff up towards the esophagus, and it's just not strong enough to keep it closed tightly. Some people discover that caffeine is a problem. So caffeine is a stimulant, and that stimulates the stomach to contract more aggressively, which means it's more likely to squeeze some stuff out into the esophagus again. If you overeat, that stretches the stomach, which stretches that esophageal sphincter open, causes a problem. If you're overweight, that puts more abdominal pressure on the stomach, squeezing things out. Or if you're pregnant, that's a temporary scenario in which the stomach is being compressed and squeezing things back out. If you have poor posture and you're slumped over, that's putting more abdominal pressure. It can also be related to the kind of food you eat. So if you eat chocolate, consume alcohol or caffeinated beverages, or high-fat foods, those are stimulants, which aggressively churns the stomach, and also high-fat foods increase the gastric retention time. So I said that the food stays in the stomach around 3 to 4 hours for a good solid meal, which coincidentally is around the spacing or time frame that we traditionally put between meals is about 4 hours, because that's about the average gastric retention time. And once the stomach is empty, then you feel hungry. But if you consume that high-fat meal, that actually increases the amount of time that the food stays in the stomach. And just by pure mathematical reasoning, the longer something's in the stomach, the more likely it is by random chance it sloshes out the wrong way. So sit up straight, lose weight, don't get pregnant or don't stay pregnant for real long if you can help it. Be careful about what you eat, maybe time things appropriately, and then you'll probably experience much less heartburn. So that would be treating the problem rather than an antacid simply treating a symptom. The long-term problems of a lot of acid reflux is that because the esophagus is unprotected from acid, chronic heartburn can actually lead to the development of esophageal cancer. If that lower esophagus gets too much acid burn over a long period of time, it can cause mutations that lead to that form of cancer. And esophageal cancer is especially problematic because really two things. One is that it often doesn't express symptoms until it is very advanced. And two, when it advances, it is very close to other things. It's right there next to the stomach. It's also next to the liver, the pancreas, the spleen, the kidneys, the lungs, the heart, the small intestines, the large intestines. All those things are within only a few inches of that lower esophagus. So if it is a late stage discovery, it's probably already spread from the esophagus to those other critical organs around it, becoming a much larger problem to solve. So heartburn is more than just an inconvenience. It could be a very serious contributor to a very potentially fatal form of cancer. So heartburn should be something that's taken seriously, and do what you can to stop it. An occasional episode of heartburn is not a big deal. Probably once every month or two I might have heartburn, and if sometimes taking a couple sips of water to rinse the acid off doesn't do the trick, I might actually take an antacid. But probably for me, once every 3 months I might have heartburn to the extent that an antacid is needed. So that's not a big deal if it's only every once in a while. But if you're having heartburn a couple times a week, that's something that you probably need to take a look at. So once the food leaves the stomach and goes into the small intestines, we get some additional contributions here from what we call the accessory organs of digestion. And the accessory organs are the liver and the pancreas. So here we have a drawing of the liver and a little sliver of what the inside of the liver would look like. And the liver basically does a number of different things, but from a digestion perspective, it produces bile. Bile is relatively concentrated digestive chemicals and enzymes that are very useful in digesting especially proteins and fats. So it's produced by the liver and goes to the down the hepatic duct to the gallbladder, where it is stored. And it's stored there in relatively large quantities. So if you do consume, let's say, a good old-fashioned southern meal with fried greens and fried chicken and all that good sort of stuff, then you have a relatively large supply of bile available so that you can dump that in there into the small intestines quickly and deal with that high-fat meal. That bile is supposed to be very runny. And so sometimes people whose diets perhaps have been a little bit too high in fat too long, or sometimes just by random chance, but that those digestive enzymes might start getting a little thick. By thick, we mean they're not watery anymore, they're getting syrupy, and it can actually form gallstones. So a gallstone is just a solidified mass of bile that sat around too long, didn't get used appropriately, and starts plugging up the system. And if it gets stuck in there, it can cause a lot of discomfort and a lot of digestive irregularities, we'll say, when you consume fatty foods because you're not getting the bile supply that you need to the small intestines. And if it blocks up too bad, it can actually cause the gallbladder to digest itself, which then dumps all these digestive enzymes out into the abdominal cavity and can cause some serious problems that way too. So gallstones and gallbladder problems are something that do need to be looked at seriously and fixed. The solution simply is, most of the time anyway, to surgically remove it. So just go in laparoscopically and remove the gallbladder completely. Then you don't have a place where those things could build up and cause a problem. The problem now becomes, though, you don't have that stored location of bile. So if you consume a high-fat meal, you don't have that good supply of enzymes to dump on it. And what normally takes about 24 hours from start to finish, so from mouth to anus, for food to be fully processed and excreted, now might take 30 minutes. So that high-fat meal, when you don't have bile for it, greatly flushes things through the system far faster than they're supposed to. If you have your gallbladder removed and the doctor didn't tell you about that already, which they should have, or if they told you and you just didn't listen, it'll only take about one of those events to occur before you realize that, I need to wait on this. And it doesn't mean that you can never have a fried chicken meal again. It just means that you need to ease into fat consumption. So over the course of a couple of months, slowly add a little bit of fat at a time into your diet. And the liver will fairly quickly learn over a couple of months that it can't count on the gallbladder. And it needs to be a little faster with making and releasing bile into the system. In a couple of months of that, and you'll probably be back to being able to eat a reasonably high-fat meal without serious problems. You notice also the pancreas dumps its contents into the small intestine in the same place the gallbladder did. And so the pancreas is going to be producing things that assist in carbohydrate digestion and in assisting some other processes throughout the body. So the pancreas and the liver here serve as the accessory organs, basically providing enzymes to finish what didn't happen to the food that needed to before it left the stomach. So once food enters the small intestine, we're going to have carbohydrate digestion resume. We're going to have fat and protein digestion complete. And so probably the first half or so of the small intestine would be focused on completing digestion. And the first half can also absorb nutrients, but perhaps the second half might do more of absorbing, a little bit less of digesting. But we see here that the internal lining of the small intestine is actually comprised of these large grooves, which would be comprised of these structures right here. And on these large flaps and folds, as the food passes through, it helps to churn and stir and mix the food. So there we're getting chemical and mechanical digestion in the small intestines. The reason for stirring it so much in the small intestines is two things. One, to mix in those digestive enzymes that were just added by this liver and the pancreas. And also to make sure that the nutrients, once they're digested and available for absorption, have equal opportunity to be absorbed. So we have these folds, and they help to stir things. If we look on those folds, there are smaller folds. And if we look on those folds, there are even smaller folds yet. So there are actually 3 different layers of increasingly smaller and smaller folds. And what that does is it increases the surface area. To absorb nutrients, there must be adequate surface area to absorb them across. And so by the time you get all these microvilli on top of the villi, on top of the folds of the intestine, if you took the surface area of the intestines, and just for reference, the small intestines are probably somewhere around 20 to 25 feet in total length in an adult. So let's just say 20 feet of small intestines, perhaps maybe the size of 2 of your fingers put together in diameter. If we would actually take the surface area within the intestines of all those microvilli on top of villi on top of the fingers of folds, we might have something perhaps, and this is just conjecture on my part, I've not seen any numbers on this necessarily, but we might have something around the area of a football field of surface area for nutrient absorption to occur. And so that allows food in that couple of hours that it's in the small intestine to finish digestion and to hopefully absorb all the available nutrients. The small intestines lead to the large intestines. So on the left here we have the ascending colon. Then in the middle is the transverse colon, on the right-hand side descending colon, which ends in the sigmoid colon, rectum, and anus. So as food enters the lower portion of the ascending colon, it is still liquid. So it's been very runny and very liquid at this point, and perhaps several gallons of liquid in the form of digestive enzymes has been added to this food. So it's a lot more watery than it was to start with. And while we're pretty much done with it in terms of nutrient acquisition, it's not of appropriate moisture level. It's far too runny, and if we were to flush it out with that runniness, we would very, very quickly become dehydrated. So actually diarrhea, which is food moving too quickly through the large intestines and not having enough water removed, is a leading cause of dehydration. So it enters the lower portion of the ascending colon there, and the reason why it goes up first, then across, then back down, is the runny stuff comes in at the lower edge of the ascending colon, and by the time it reaches the top of the ascending colon and goes across the transverse colon, which is going to be right underneath your rib cage, by the way, it's starting to go from runny stuff to perhaps sludgy stuff. And by the time it starts to enter the descending colon, it's definitely becoming more of a solid. And then by the time it reaches the sigmoid colon, it is finished fecal material. And really probably most of the descending colon contains finished fecal material as well. So the job there was to take out the extra water, leaving the right amount. So what's the right amount of water? And the answer to that is the right amount will allow you to have a bowel movement without effort. It simply means you give permission for the large intestines to empty, and with no additional effort on your part, the fecal material is expelled. If it takes any kind of effort on your part to have a bowel movement, then the large intestines have removed too much water. What that might mean is it might mean you need to drink more water, but you also can address this by consuming more fiber. Fiber is non-digestible carbohydrates, which from a digestive perspective retain water. So as they retain water and move through the intestines, that ensures that the fecal material stays more moist. And so you want it moist enough that it easily voids from the body again without that effort involved. Fiber also helps you to feel full faster, and because it's non-digestible, it's pretty low calorie concentration. So low calorie helps you to feel full while actually consuming fewer calories and less food in general for that matter, and helps with intestinal health and ease of a bowel movement. Now if you get too much fiber, it can cause the bowel movement to occur too rapidly because the fecal material can retain too much liquid. There's a happy medium there, and again, as long as you're having effort-free bowel movements that don't cause any pain or other issues, then you've got somewhere around the right amount. While that food is going from liquid to a more appropriate solid consistency, there are bacteria in the large intestines that are eating what we couldn't. So everything we could get out of it at this point has already been gotten out by the small intestines. The bacteria have a chance at it, and the bacteria then produce some vitamins and some other things that we couldn't on our own, which we then absorb along with the water. So the bacteria get a place to live and food supply, and we also, from the bacteria, get some nutritional benefit as well. Without having those bacteria in the large intestines, we would probably have some serious nutritional issues. It also helps to keep this part of the body from becoming overwhelmed with pathogenic bacteria. And actually, probably 95+% of the dry weight of fecal material would be bacteria, and of that, at least 95% is probably E. coli. Now, you know about E. coli because you know it causes food poisoning. It causes food poisoning if it's somewhere other than the large intestines, and or it's not the right variety. So the right variety is whatever you're used to. So around here, you've got Western Kentucky or Western Tennessee E. coli, or wherever you happen to be living right now, that variety, and it's a balanced system. But if you go somewhere dramatically different, let's say Mexico, so the Mexican E. coli would be significantly different than ours, those two would then fight between each other, and that's what produces Montezuma's revenge, the bloody explosive diarrhea that you get if you drink the water or eat the wrong thing in some places. And that's simply a different variety of E. coli entering the system, and it's not necessarily intending to hurt you, but it's simply fighting for the right to occupy your large intestines, and once it defeats your E. coli you already had there, then the symptoms go away. The problem is when you return to Western Kentucky, Tennessee, or wherever you normally reside, those E. coli will enter the system, and so it becomes a 2-for-1 special. You get 2 rounds of this wonderful diarrhea, once when the variety changed to the foreign kind, and then once when that foreign variety was overwhelmed by your quote-unquote native variety, and then you're back to a normal balance again. That would probably then drastically change your spring break plans forever afterwards if that were to occur. But that E. coli, if it's your native E. coli, doesn't cause any problems and actually outcompetes pathogenic bacteria. Because there are so many, in this case, harmless bacteria in the system, there's not adequate food for pathogenic bacteria to eat and survive and reproduce. There's not a place for it, so that helps to prevent disease by just simply having a system full of harmless stuff already. The harmful stuff doesn't have much of a chance to take over. Some other problems can occur with inadequately moistened fecal material, and most of those are going to happen down at the rectum and anus. But one thing that can happen in the descending colon is called diverticulitis. And what happens there is if that fecal material is too dry, it can actually stretch the large intestines, again, most commonly in the descending and sigmoid colon, and stretch and form a little pocket off to the side. That pocket can build up with stuff, and it can become inflamed and swollen and could actually theoretically rupture into the abdominal cavity. So having adequately moist fecal material doesn't overly stretch the large intestine. The more common problems occur down in the rectum and anus when that too dry, too large fecal material shoves through there, and it can cause tearing of the rectum and anus, commonly referred to as anal fissures. Those are actually more common in young people, and the older you get, probably because muscle tone and tension declines as you get older, anal fissures become less of a problem for older folks. A fissure that doesn't heal properly, and this can also, by the way, often express as some bleeding immediately after a bowel movement. Most of the time, anal fissures are self-curing in a couple of days and no big deal, especially if you adjust your fiber to accommodate. If an anal fissure fails to properly seal, it can lead to the development of a fistula, which is basically the fissure partly sealed but didn't seal all the way, and fecal material starts traveling behind the sealed flap, trying to then push its way out through what would be a different opening to the body. So that would be a problem there. The solution for fissures, again, is just to adjust your fiber intake and allow less stretching to occur. Typically heals on its own in a couple days. The solution for a fistula is surgical, basically slice it open again and allow it to heal as it should have the first time. That's a little bit more of an invasive process. Another problem, it's a very common problem in this region, is the development of hemorrhoids. And so the blood vessels in this region, if there's excessive pressure, actually get kinked off and have some spontaneous muscle contractions there. that cause the blood flow to be impeded, and then blood backs up behind this blockage area, swelling the blood vessel, swelling the surrounding tissue, and becoming painful. The solution for that is sometimes it goes away on its own with no input or effort. Sometimes you might need to use some steroidal creams to reduce the swelling and allow it to straighten out and heal on its own. Sometimes they can add in some suppositories on top of that, perhaps to help. In a more extreme case, they could go in and either surgically cut it out or band it, which is basically putting a really strong rubber band around the hemorrhoid itself, which cuts off its blood supply. That little piece of tissue dies and falls off. The rubber band falls off too, and away you go. Older people especially have more of these issues because they have a crummy diet, and they don't have enough fiber in their diet, and they don't drink enough water, and so they're then becoming almost addicted to laxatives and things like that. When you go to the, let's say, the pharmacy, you might find the digestive aids aisle, as it's now called, contains lots and lots of different laxatives and fiber supplements and that sort of thing, all geared towards making sure your fecal material is adequately moist. Or you could just eat more fruits and vegetables, drink more water, eat more whole grain products, and life will be good. So lots of wonderful topics here to finish out the idea of digestion. I'm glad I could make your day so much better. When we switch from digestion and talk about nutrition, I'm not going to spend a lot of time talking about nutrition here, but we do want to talk about a couple things, and one of those is a BMI. A BMI is an attempt to have a non-subjective, so as an objective as possible statement of, are you appropriately sized? Are you too thin? Are you overweight? Are you just plain fat? Or where do you fall in this process? So this is trying to take personal opinion out of the mix and actually give it a number, which then gives you an answer. This is not a perfect system, but it's a little bit more scientific than just how you feel about yourself. So you can see here the healthy BMIs range from around 18 to about 25. Overweight from 25 to 30, obese from 30 to 40, and over 40 we would call morbidly obese, which would mean not just pretty fat, but it's a problem that's actually going to cause additional health complications. So a BMI is calculated by considering two general things. And you can look at a doctor's BMI chart, and it's going to contain a little bit more information and calculate some other things in there at the same time to make it a little better. But this is a good general idea of what's going on. It's taking into account height and weight. Now obviously that's not the only thing that goes into making a person fat or not. So maybe a person, let's say, is very muscular. And because muscle weighs quite a bit per volume, it might suggest you're overweight here. So what I would suggest is take your BMI chart answer and apply common sense to it and see if it stands. So you look at your height and your weight. So let's take me for example. I am 6 feet 1 inches tall, so that puts us over here. And I weigh 243 pounds. So if we go over here to 6'1", 243 pounds, it's going to put us about right in here with a BMI of around 27 to 28. Okay? If we go back here and look, that says that, okay, I don't mind this number so much. It says I'm overweight. I can't disagree with that. These charts used to actually put me in the obese category, and I never considered myself obese. Oh no, it did actually put me in the obese category. I looked at the numbers wrong, sorry. So here I'd be over here in this category here as obese. So yes, I still don't like this chart. But to look at me, I've asked a number of people, do I look obese? And the average answer is no. And I think they're saying that with honesty, not just worrying about their final grade in the class. But the point is, use some common sense. So if I was right here, that put me, let's say, on the edge. of this category. I wasn't very far off from overweight. I wasn't very deeply into the obese range. If it had put me, let's say, over here with a BMI of around 33 or something like that, or up in here in this range, then it would have been more obvious that that was the case. So if your number puts you in the middle of a range, then that's probably really where you are. If it puts you on the edge, you can go either way you want with that and probably be all right. Along with assessing, am I fat or not, you can look at this BMI chart, but you can also ask yourself this. Really two questions. One is, am I happy with the way I am? And I wouldn't want to put too much emphasis on that, because not being happy with the way you look, even when you should be, is the basis for a lot of eating disorders. Anorexia, bulimia, muscle dysmorphia, a number of things that are actually psychological disorders in which a person perceives themselves to be different than the way they are. And that's probably the reason this chart was come up with in the first place, was to take feelings out of it and try to make it as much of a number rather than a feeling. But we do want you to be happy with the way you look and feel. Certainly that is important. But perhaps the more important consideration here is, what is your body size doing to your health? Is your body size negatively impacting your health? And if it is, then you do need to do something about that. So typically the BMI chart will give you an idea of, do I need to look at my health? So if you're in the overweight category, is that causing any problems to your health? Maybe. It just depends. But if you're solidly in the obese category, definitely that's going to cause some health problems. And for me, I can tell you my knees hurt. My feet easily hurt. So if I would get myself from that obese edge to the middle to bottom half of overweight category, then I would not have knees that hurt nearly as much. My feet wouldn't hurt as much, and I would feel much better. I have a nephew who is 6'6", which is top of the chart here. And by the way, he's 19 years old for reference here. And he weighs, I'm guessing, my best estimate, somewhere between 450 and 500 pounds. He's a big fella. And so at this height, we've got this height here, but the chart only goes to 275. So if we took it on over to, well, off the charts here, it would probably come up with a BMI of around 60 if we had to go out and put a number on it, which is way past the cutoff for obese. So it definitely would fall in the obese, definitely in the morbidly obese category. So for him, health risks would include obviously joint damage, bearing all that weight. He's going to have heart problems because your heart gets overworked supplying that much body mass with appropriate blood flow. He got that way because of his diet and lack of exercise, so he's probably headed for diabetes if he isn't there already officially. So a number of cascading health problems are going to come his way if he doesn't get his BMI down. And until he changes his lifestyle, that's not going to happen. Another perspective on health here is what you eat. What you eat has a lot to do with your health, and this is just a comparison of some different fats. In the world of fats, there are saturated fats, unsaturated fats. And in the world of unsaturated fats, you can have mono or poly. Monounsaturated means you have, if you recall from our discussion in chemistry, you have a single double bond that causes the shape of the fat to change and keep it liquid at room temperature. Polyunsaturated fats have multiple double bonds, which means they're even more changed in shape. They're even more liquid at room temperature. So the question at hand here is, which kind of fat is the healthier fat for you? We like to cook. Fat gives some moisture. Fat gives some taste. And so it's useful in those ways. And it's sort of interesting here to look at these six, perhaps probably the six most common types of fat you might encounter in your cooking, and how much of them is saturated, mono, and polyunsaturated. And so interestingly, a lot of people like to use coconut oil, and there's this misconception out there that coconut oil is actually healthy for you. But when we look at the fat percentages here, what we find is that 82% of coconut oil is saturated fat. So of the 6 on the list here, coconut oil is the most unhealthy, because saturated fat is more likely to cause cardiovascular disease, blockage of arteries, that sort of thing. So coconut oil is actually worse for your health, your cardiovascular health especially, than is beef. Butter, unfortunately, is a little bit worse than beef. Olive oil isn't that awfully healthy. It's a lot better, obviously, than the other things, but it's not as healthy as regular canola oil or safflower oil. Probably the healthiest of these, if we look, would probably be safflower oil, closely competing with canola. It has a little bit more saturated fat, but it has a lot more polyunsaturated. So the more unsaturated the fat is, the healthier it is. So while olive oil had a lot of unsaturated fat, it was mostly monounsaturated, not as much poly, and so that made both safflower and canola healthier. And again, trade-off there, safflower has more saturated, but it's got so much more polyunsaturated that probably cancels out the advantage that the canola oil had with the lower saturated. The point here is, you don't need to be using a whole lot of any of these because they're all high in calories. So when you choose them, be reasonable, but try to choose them more towards the left-hand side of this table and less towards the right. Certainly take the coconut oil and chuck it. It's not good for anything, in my opinion. Hopefully that all made sense and you learned a lot. And thanks for joining us. Have a good day. We'll see you next time.